Okay, 3.6 part 2. My plan is going to be very similar to part 1. I'm just going to work out several problems for you. And as you do this assignment, you're going to be watching me work out the problems, so that's all you need to do as far as the PowerPoint. I've given you the slides and stuff, and all you do is work out the problems that we do during this lesson, and then that will be your homework. And so anyhow, let's get started. Okay, so we're going to realize now that sometimes you have to check your solutions because sometimes they won't work in the original equation. So we'll see a bit of that in this lesson. So we could start off by reviewing a little bit. This is what we were doing in class today. I have problems like this. And the first thing you want to do before you get rid of these exponents is to move these numbers. Any loose numbers on the side we'll take care of. So I'm going to add 9. And this gives me x minus 4 to the 2/3 power. Okay, and so this would give me 25. Now, you could get rid of this whole fraction at the same time by raising this to the 3/2 power. But I think what I'll do is I'll do this in separate steps. I'm going to raise this whole thing to the 3rd power so that this 3 will cancel off the 3 there. But I also have to do the same thing over here. Okay, so this 3 cancels off this one. So now I have x minus 4 squared is equal to this number, 25 cubed. And this is a pretty big number, 15,625. And now what I'd like to do is take the square root on both sides of the equal sign, and that will cancel off this square here. But remember, I'm solving for x. And anytime you have an x squared, something like this, say x squared equal to 16, well, we know that there's two answers that would work here for x. X equal to 4 would work because if you square 4, you get 16. And x equal to negative 4 would also work because if you square negative 4, you get 16 also. And so when we take the square roots of squares, we realize that the answer is going to have plus or minus over here. And so we end up with a 4. So at this step here, when we take the square root on both sides of the equal sign, and since we're solving for x, we don't know which one we have here, so we'll put plus or minus in here. Anyhow, we'll take the square root here, and as we do that, we're going to add in a plus or minus right there. And so this square root cancels off this square, so we have x minus 4 is equal to the square root of 15,625. And when I do that, I get plus or minus 125. Okay, so now I'm going to add 4. Add 4 over here. And I get x is equal to, let's see, if I consider the positive answer, I'll have 125 plus 4, so I get 129. And now I need to add the word or, because I could use the negative answer here. Negative 125 plus 4 would give me negative 121. So x is also equal to negative 121. Okay, so now before we go much further, we should check and see if these answers would work in the original expression up here. And if they don't, we have to eliminate them from our list of answers here. So if I take 129 and I substitute it in right here, I would get 129 minus 4 which would be 125. And then if you raise that to the 2/3 power, you get 25. So 125 to the 2/3 power would give you 25. And then you get 25 minus 9, which is equal to 16. So this answer works. Now, if we try this answer on the other hand, okay, try this out. If we try negative 121, 121 minus 4 is negative 125. And we want to raise that to the 2/3 power. And so, let's see, is that going to work? Let's try this out. And I get what's called a domain error when I do that. I'm not quite sure why it's a domain error. Because what do you do is oh, I see what the problem is. Okay, so let's try this out. If we were going to solve this, let's see what would happen. Okay. Okay, so let's see what happens here. If we were to put the 121, we'd have to the 2/3 power, we'd add 9 over here, right? We'd add 9 over here. And so we'd have negative 125. And we'd have 2/3 power is equal to 25. And then remember what we're going to do here. We're going to have what? We're going to have to cube things first. Okay, so we're going to cube this side and cube this side. And this cube would cancel off with that one, right? So we have negative 125, okay, squared is equal to 25 cubed. 25 cubed. We'd have a 15, 6, 25. Okay, so now if we took the square root to cancel off the square, take the square root here, normally we'd have a plus or minus here when we do the square root. And and now what happens is that this square root would cancel the square, and now we have negative 125 equal to, well, there's a little bit of a problem here. We have a negative number that's equal to like a positive number. Oh, you know what? Hold up. You don't have a plus or minus this time because we're not solving for x. And so we have, if we took the square root here and the square root here, this would be square root, that's equal to 125. And the square root of 15, 625 is equal to 125. It's not equal to negative 125. And so there you have it. This does not lead to a solution to our original equation. So that answer we'd have to eliminate. We'd have to say this does not work. That's what we call an extraneous solution. So there you have it. Here's another one that's going to happen. We'll just see what happens here. To get rid of the square root, we're going to square both sides, okay? So we're going to square this side. Well, I have to square this side. Now, a lot of people make a mistake when they're squaring this. They say x squared plus 1 squared, which is 1. That is wrong. It's not quite correct. So let's see what we should get. When you're squaring this, you should get x plus 1 times x plus 1. After all, that's what this exponent means. It's this expression multiplied by itself twice. Well, to multiply this out, we use the FOIL method. FOIL. Okay. So first times first gives us the x squared. And then outside times outside gives us 1x. And then another 1x from the inner product. And then last times last gives us plus 1. So when we multiply this out, we should get x squared plus 2x plus 1. Well, when we square this side, these cancel, of course. So we simply get 7x plus 15. And so we'll just rewrite it again here. Well, now this is a quadratic, something that we should have had in chapter 1. And we know how to solve this. We're going to use the principle of zero product. So we want to move everything to one side. So I'm going to subtract 7x here, subtract 7x here, remove the 15 at the same time. And this gives me x squared plus what? Whoops, that's a minus, isn't it? Minus 5x, and then minus 14. So this is equal to 0. So now if I can factor this, I will. But if I can't factor it, I'll use the quadratic equation or complete the square or something like that. But this looks like to me it does factor. So I get x minus 7x plus 2 here. But this is equal to 0. So now I use the principle of zero products. From here I get x is equal to 7. And from this one I get x is equal to negative 2. Okay, now you have to be careful here. You have to check your answers in the original expression and see if they work. So let's just take a look up here at the original expression. Okay, does it work when you plug them in? And sometimes one of these won't work, and sometimes both of them won't work. And of course, sometimes you put them both in and they both work. So if you put a 7 right here, on this side you're going to have 6. Excuse me, you're going to have 8. Because 7 plus 1 is 8. Okay, well if you put 7 here, 7 times 7 is 49. And if you add 15, you're going to get 64. And if you take the square root of 64, you get 8. So you get 8 is equal to 8. So sure enough, that one works. If you put the answer in over here, the negative 2 in, what do we get? Well, in that case, we get negative 2 here. Negative 2 plus a positive 1 is negative 1. And I hate to tell you, but square roots are always a positive number, so you can't take the square root of a number and get a positive, a negative answer. Anyhow, let's carry it out. Let's check this out. If you put in a negative 1 here, you're going to get what? Negative 7 plus 15. That's the square root of, say, 8. The square root of 8 doesn't equal negative 1. So what this means is that that solution is extraneous. It came about when we were squaring both sides. That introduced an extra degree into the equation. See, when we first started here, this was degree 1. But when we squared both sides, we have degree 2. And so now we'll have two solutions. It's just one of them might not work. And sometimes both of them won't. So this one's eliminated. And you're expected to eliminate your answers. You're expected to always check your answers. So anyhow, interesting problem. This one, you can try it. So you can pause the video and try it on your own first. It's good practice. I'm assuming you're doing that. But anyhow, we'll square both sides. Now we'll get rid of the square root. Square this one. And of course, if we square this side, we cancel out the square root, so we get x minus 6. And this one is going to be x minus 8 times x minus 8. And what's that going to give us? It's going to give us, from the first product, we're going to get an x squared. The outer product is going to give us a negative 8x, and the inner product is going to give us negative 8x. So if we combine those two, we get a negative 16x. And then finally, last times last gives us a positive 64. Well, just like the last problem, what we want to do is move everything to one side. So I'm going to subtract x here, subtract x here. I'm going to add 6 here, add 6 here. And I get 0 is equal to x squared minus 17x, minus 70. So once again, if we can factor this, it's probably faster, but if you can't, you might have to use the quadratic formula. So let me just remind you, the quadratic formula, x is equal to negative b plus or minus the square root b squared minus 4ac divided by 2a. Should have that memorized by now, but anyhow, if you cannot factor this, use the quadratic formula. That will probably be the fastest way. Okay, but this does factor, I think. Let's see, we've got to get negative 17. And I was thinking this was, oh, this is a positive here. Okay, so if we use negative 10 times negative 7, that would give us the middle term right here. So we get x minus 10 and x minus 7. But this is equal to 0. So in this case, we get x is equal to positive 10. And we get x is equal to 7. Using the principle of zero products here. And this is stuff we did in chapter 1. So a little bit of a review of chapter 1. Anyhow, we should go back and see if these work in the original expression. So quickly, we can usually do this. If we were to take the 10 in here, we get 10 minus 6 is 4. And 10 minus 8 is 2. But the square root of 4 is 2. So this equation, or that solution, works. If we try this one into here, we get 7 minus 6, which is 1. And 7 minus 8 is negative 1. And square root of 1 is 1, but that does not equal negative 1. So this answer here is extraneous. It's a wrong solution. Now, please be careful, my friends. Don't always exclude the smaller number or the negative answer. There are many cases where the negative answer does work. And so try not to make assumptions like that. That would be kind of foolish. Okay, so now we have the last type of equation involving radicals is the situation where we have two radicals. And basically what we have to do in this type of problem is square both sides and then clean things up with some algebra. And then what we have to do is square it one more time. And after that, we then solve the equation. And it might involve the quadratic equation at that point. So these can be kind of annoying, and they can even take up a half page of paper sometimes. So you just need to be patient and work it through till the end. And then finally, you have to remember, check your solutions. It may turn out that none of them work. In that case, you have no solution. Well, so let's get going. I'll try to do this kind of quickly here. If we square this side and square this side, on this side we get rid of the square root. So we're going to simply have 3 minus x. But if we square this side, aren't we really going to just have another factor over here? The same thing again. So since we're going to have that, why don't I just write it down here and we'll get started on multiplying this out. This can be a little bit tricky. So first one times first one. If you take a square root and multiply it by itself, the square root cancels. Because you're going to have a square root squared. You know, if you multiply it by itself, it's squared. Well, the square cancels the square root, so you get the thing on the inside. So first times first gives me x plus 2. You see what would have happened? We would have had x plus 2, and we would have had this squared. Well, the square cancels out the square root, so you get x plus 2. Alright, well, moving on to the outer product. Outside times outside. Well, that's 1 times the square root. So we get plus 1 times the square root thingy, x plus 2. We can think of it as a 1 in front. And then we have the inner product. It's going to give us another one of these. So if you have another one of these, 1 times x plus square root 2, and you're adding these, like if you have a square root of 3 and you add this plus the square root of 3, then you have 2 of them, 2 square root of 3, right? Well, the same thing is true here. Why don't we just erase this and put a 2 right there? There you go, that sticks. And then finally we have the last times the last, which is a plus 1. Because 1 times 1 is 1. Okay, so as you see here, what's happened, we started out with 2 square roots, and after we squared both sides, we got rid of the square root on this side, but we still have a square root. So here's the basic idea. Move everything to the other side of the equal sign except the square root thingy. And then you're going to square both sides again. So what we're going to do is we're going to subtract x here, subtract x here. Oh, by the way, this 2 plus 1 actually gives us 3, right? So let's subtract 3 here and subtract 3 here. Hey, that works out kind of nicely. That subtracts off, and so that subtracts off. And so then we have this 2, and we have x plus 2 is equal to negative 2x. Okay, so now we can get rid of this 2 because it's being multiplied. So I'm going to divide by 2 and divide this side by 2. And I have the square root of x plus 2 is equal to, well, this cancels out this, I get negative x. Okay. Well, at this point, you should know that there's something fishy going on because this side is a positive number and it's equal to a negative number. Well, unless x itself is negative. Well, so let's see what happens if we square this side and we square this side. Then the square is going to cancel out the square root, and I have x plus 2 is equal to negative x times itself, negative x times negative x is equal to x squared. So I have an x squared here. Alright, so just as in the previous problems, I have to move everything to one side. And so the principal zero product tells me I'm going to have an x squared. Now can we do this in our head? If I move that x to the other side, I'm going to get negative x, right? And if I move the 2 over, I'm going to get negative 2. Okay, so now we just factor this if we can. If we can't factor it, again, we'll use the quadratic formula. But I think this does factor, so I'm going to get an x minus 2 and an x plus 1. Remember, I have to get the middle term. And so if we use negative 2 times a positive 1, those two when added give me a negative 1. So this gives me two solutions then. I get x is equal to 2, and I get x is equal to negative 1. Now the very important step here is to try these both into I'm going to rewrite them up here. I've got x is equal to 2 and x is equal to -1. Okay, so if we try this in our original equation, see if they work, what happens? Okay, so if we put a 2 here, we'd have 2 plus 2 and square root of 4 is 2 plus 1, which equals 3. If we put a 2 here, we'd have 3 minus 2, which equals what? 3 minus 2 is the square root of 1, which is equal to 1. So this side, we end up with 3 equal to 1. Well, clearly that answer does not work. Alright, so now let's restart. And let's try the other answer. If we put in a -1 here, well, that'll give us -1 plus 2. -1 plus 2 is 1, and the square root of 1 is 1. And then we add that to the 1 here, and we get 2. Okay, so this side is 2. If we put a -1 here, well, then a negative of a negative gives us a positive. So that's actually the square root of 4. So 3 plus 1 is 4. And the square root of the square root of 4 is 2. So in this case, this answer did work, and it's the one that's negative. And this one that was positive didn't work. So again, my friends, do not make assumptions about your answers. And in some cases, you haven't seen it yet, but there will be some cases where both answers do not work. Anyhow, those problems are kind of annoying. They take a while, and you just have to be careful step by step, and that's pretty much how we do these problems. And so, let's see. I don't think we're going to do this one. These are kind of boring. I don't want to do them all over again. So on your homework, you can skip this problem as far as the PowerPoint. And we'll get to here. Central question, why is it necessary to check every apparent solution of a radical equation? Well, because some of the solutions might not work in the original equation. And we have to eliminate those. So, that's the end. Whoa.